Okay, so we're back. Hopefully we're playing around with all of the different tiles that we can find. And so if we were to try to create a rectangle, hopefully we kind of moved these pieces up. So notice that if I keep moving these pieces up and I'm going to turn this guy over, we should have a perfect rectangle here. Okay, so it's a little hard to recreate this picture, and I can't draw on it using my fun colors. So I'm going to go ahead and I'm going to kind of look at this picture and almost snapshot it and kind of redraw it over here. So let's take a look at this. So I'm just going to bring this out just a little bit more. So it kind of looks like a rectangle, and then here, so we have 1, 2, 3, so almost like that. Let's draw a little bit better. Hold on, I think we can draw a better one. All right, so too thick. Third time's a charm. Okay, so here is our x squared. And then I have 1, 2, 3, 4. And then I have 1, 2. So again, these are x's. X and x, 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 x. And then I have little ones. All right, best of my ability. Bam, bam, bam. And again, these are ones. Okay. So if I was talking about this, area can be written as length times width, right? We want to figure out what are our dimensions, right? Because if I so happen to take a rectangle and it was 3 by 7, not that this is really 3 and this is 7, I'd say 3 times 7, so this would be 21 on the outside. If I make this x, this now becomes 21x, right? And so I want to figure out what is my length, what is my width in order to get all of my individual rectangles. So I know that this is going to be an x, and then this will be an x, and then if this length is x, this length is x, which means that this is 1, 1, 1, and 1. And then if this length is x, that means that this length is also 1. And so all together, this length right here is an x plus 1, 2, 3, 4. So x plus 4. And then this length right here is an x plus 1, 2. X plus 2. So how can I write it as length times width? We're going to write it in a binomial. We're going to say x plus 2 and then x plus 4. Right? So again, length and width. And it does not matter, 3 times 7 or 7 times 3. It's going to get us the same answer. So when I look at a question like this where it says, write an equation that shows that the area written as a sum is equivalent to the product. So this is what's known as the product. So what I want to do is I want to say x plus 2 and x plus 4. And then what is the area as a sum? So sum just means I'm going to add up all my pieces. So I'm going to add up all my individual pieces. So I have 1x squared. I have 1, 2, 3, 4, 5, 6 x's. So 6x. And then I have 8 little ones. So I have 8 little ones. So again, this is as a product because it's multiplying. And then this is as a sum. All right. So what I want you to try to do, and again, I want you to guys pause the video, and I want you to try to sketch a rectangle. And again, you can use your the rectangles and the algebra tiles over here to kind of recreate some of these. Okay, some of these are going to be a little bit harder. Some of them are going to be a little bit easier. I'm not going to necessarily create all of these rectangles when you come back from unpausing it, but I will give you the answers of all of the length and the widths. So go ahead and pause the video now and try a few on your own. All right, so if you're coming back, we're going to try a few on our own. So let's just start with A, because I imagine most of you guys probably did A. So I have 1x squared. I have 3 of these x's, so 1, 2, and 3. So I'm going to go ahead and kind of maybe put them right here, see what happens. I have 2 1s. So most of the time you're not going to be able to do this, right? Because notice it's not a rectangle. So what I like to do is kind of go back and forth between putting an x here and putting an x here. And then here are my answers, right? So here's a lovely rectangle. So notice that this would be an x, and then a 1 and a 1. So this right here would be an x plus 2. So the top would be x plus 2. And then over here would again be an x and then plus 1. So here would be x plus 1. So we have a rectangle. Let's try B. Let's see what happens for B. So I need 6 of these x's. So 1, 2, 3, 4, 5, 6. Cool. And then I need 15 of these. So 1, 2, 3, 4, 5, 6. Let's go 7, 8, 9, 10, 11, 12, 13, 14, and 15. So this one didn't work out the way I wanted to. So let's kind of play around with this and see if we can manipulate it a little bit more. So let's turn these around. Let's make it look maybe like that and see if I can move this. So maybe take some of these out, see if that works. Ooh, here we go. This is starting to be promising. Okay, so here we go. Oh, nope, did not be promising. All right, good, playing around with it. Let's move the, oh, here we go. There's a rectangle. Figured it out. Beautiful rectangle. So what do I have? I have x plus x, which is 2x. I knew if I played around with it long enough, I'd figure it out. So I got 2x, and I got 1, 2, 3, 4, 5. So plus 5, and then 1, 2, 3. So I have a 3 on the outside. I can put the 3 on the inside. All right, there we go. Let's try another one. So I'm going to go ahead and take this one away and bring that away. Let's do a little harder one. Let's do H. That seems like a fun one. So 1, 2, 1, 2, and 3. So how about something like that? And then I'm just going to add that one here. How many do I need? I need 4. So I'm going to do something like this. Let's see what happens. If I do this, 1, 2, 3, this would be 4. But I only need 1 of those. That obviously did not work. All right, so, but here we go. Let me move this up here. So there we go, rectangle. So again, this would be x, 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 and then plus 1. So over here, we would say, I'm going to move this over so we can kind of see it a little bit better. What did I say, this one? So this would be x plus x plus x. So 3x, and then plus 1. So plus 1, and then over here, x plus 1. So x plus 1. Okay, so again, hopefully you guys played around with these a little bit more. Let me kind of give you guys, let's do one more. So let's do one more. Let's bring this away. Ooh, nope. Those are gone. Okay, so which one should we do? J looks interesting. J has the xy in it, so let's do that one. So I got 2 xy's. So let's bring those out. So 2 xy's. I got 4 y's. So these for sure have to be attached right here. So let's attach those to 4 y's. And then I need 1x. Let's add, oh, this is going to work out perfectly this time. So there we go. So if this is y, that means that this has to be y, and this is y, and then this is 1. So this problem would say y plus y, so 2y, and then plus 1. And then over here, this is an x, and then plus 2. So x plus 2. So here's some more answers. It is okay if you did not get all of them correct. You'll get some extra practice with this the next time. So the green ones are the ones that we did not do and create a rectangle. So this would be x plus 3 and x plus 2. This answer is x plus 1 and y plus 1. This answer would be a 2, x plus 4, and then we can do an x plus 3. This actually has multiple answers, so that's just one of the answers that we could have said. 2y and a y plus 3, and then this one is a y plus x and y plus 2, and then finally this one's actually 3. X plus y plus 1 and x plus y plus 2. So again, if you want to try a few more, I want to make sure that you guys say that these two are equal to this. This is equal to this. So we want to make sure that we use kind of an equal sign. Again, all of these were the sum. And then this is the product. So we want to make sure, bring this back in. What we want to make sure is that we can say the area of the sum is always going to equal the area of the product. So again, if I have x, oops, I wrote it wrong. So if I have, say, x squared plus 3x plus 2, again, area of the sum because they're all addition, and then I say that this is x plus 1 and x plus 2. Order for the product does not matter. Okay, the order technically for the sum, we always want to start with the higher degree and then work our way down. So notice that this is a squared, power of 1, and then nothing. I'll make sure that the next time we work on this, we'll work on our area or for the order and things like that. But again, the product does not matter because it's like saying 3 times 2 or 2 times 3. They both give us the answer 6.